Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. Yes, children. So, I'd asked you to complete this. So we'll just maybe you've understood some of them. You have a doubt. You have some doubts in a few of the others. So let's discuss all the answers today. Yeah. So who can explain this? In this figure, we need to find the value of the unknowns. X. I can see X and Y. Yeah. Yes, children. How do we find X and Y in this figure? What do these indicate? What do these indicate?
They are equals, ma'am.
Ma'am, they are parallel.
Parallel lines. These arrows indicate parallel lines. So that means BD is parallel to FG. BD is parallel to FG. BD is parallel to FG. These arrows, see here, double arrows here and here. They indicate that BD is parallel to FG. And what about this? What about this? What does that indicate?
AB is parallel to DF, ma'am.
AB is parallel to DF. AB, you can say AB or you can say BA is parallel to, you can say DF or you can say FD. Both are the same. So it indicates that these two lines are parallel to one another. So we have two pairs of parallel lines. We have two pairs of parallel lines. So you can use the properties of corresponding angles, alternate angles, co-interior angles, because we know when two lines are parallel to each other, alternate angles are equal. When we say alternate angles, both interior and exterior. So we know that alternate angles are equal, corresponding angles are equal, co-interior angles are supplementary. So when we have a pair of parallel lines, we can use these concepts: alternate angles, corresponding angles, and co-interior angles. All right. So that's about it. And you can also see triangles. You can see triangle ABC. You can see a few triangles here. So maybe you can use the exterior angle property. You can use the exterior angle property. Exterior angle is equal to the sum of the two interior opposite angles. Maybe, see, we're just trying to plan like what all concepts can be used here in this situation. So since we have a set of parallel lines, as we discussed, alternate corresponding co-interior angles. These rules can be used. We have triangles, so exterior angle is equal to the sum of the two interior opposite angles. Okay, then also when two lines intersect, vertically opposite angles are equal. When two lines intersect, vertically opposite angles are equal. Okay, when two lines intersect, two pairs of vertically opposite angles are formed. See, this is one pair. This is one pair. Angle 1 is equal to angle 2. Angle 3 is equal to angle 4. When two lines intersect, see, they can intersect like this also. They need not form a perfect X like this. The two lines need not form a perfect X like this. Need not form a perfect X like this. So it can be, one line can be like this, the other can be like this. When two lines intersect, two pairs of vertically opposite angles are formed. So this is one pair, this is one pair. Angle 1 is equal to angle 2. And this is the other pair. Angle 3 is equal to angle 4, is equal to angle 4. So maybe we can use, we have to use the concept of vertically opposite angles. So let us see. Now we need to find X and Y, children. See here, X and Y, X and Y. So I have marked this angle as A and this angle as B. See, now you will, as soon as you see this figure, how will we know that we have to mark A here and B here? Actually, we won't know. So let's start working. How will you know that you'll have to mark A and B here? We don't know. So the thing is here, parallel line, transversal, parallel line. Can you see that? Parallel line, transversal, parallel line, like a Z. Parallel line, transversal, parallel line. Here are the pair of alternate interior angles. Here are the pair of alternate interior angles, here and here. Because here, these are the two parallel lines. This is the transversal. Where are alternate interior angles found? on either sides of the transversal, on either sides of the transversal. And when we say alternate interior angles, both are interior angles. So both are interior angles and they're formed on either sides of the transversal. So see here, if you produce these lines, here produce this line, and produce this transversal, produce a transversal. Now you can see here, here 55 degrees is on the left side, on one side of the transversal, and you can see A on the other side of the transversal. See here, watch carefully. These are the two parallel lines. This is the transversal. This is the transversal. Which are the four interior angles? See here, 1, 2, 3, 4. These are the four interior angles. These are the four interior angles. See here, 1, 2, 3, 4. These are the four interior angles. 1 and 4 alternate interior angles. 2 and 3 alternate interior angles. So sometimes when you can't make out, the alternate angles, just produce the lines, produce the parallel lines, extend the transversal. Then you can see it fully. So now I'm talking about 1 and 4. So you want to write that 4 is equal to 55 degrees because alternate interior angles are equal. So because you want to write angle 4 is 55 degrees, I've taken that as A. So only when you come to that point, that is this angle is 55 degrees, then you realize that you have to mark, or you can write angle BDF. How do you call angle A? Angle BDF. You can use that also. But I normally mark so that it's easy to, when you want to check your answer, it is easy to make out what you've done. So I've marked this one as A, parallel line, transversal, parallel line. Here, so you can see the Z formed. Here and here are the alternate interior angles. Similarly, see here, parallel line, transversal, parallel line. Here are the alternate interior angles. Parallel line, transversal, parallel line. Here are the alternate interior angles. Parallel line, transversal, parallel line. Here are the alternate interior angles. Alternate interior angles. Here are the alternate interior angles, which are equal when the lines are parallel. So here we know that these two lines are parallel. So these are the two parallel lines. This is the transversal. So we can see that Z kind of formation, parallel line, transversal, parallel line. So alternate interior angles are equal. A is equal to 55 degrees because AB is parallel to DF. You should write that. You should mention the parallel lines. So these are the two parallel lines and BD is a transversal. Alternate interior angles are equal. So what should you write as the reason? You should mention the parallel lines. You must mention the transversal and then say that they're equal because they're alternate interior angles. They form a pair of alternate interior angles. So see here, AB, parallel line, transversal, parallel line. So AB is parallel to DF. AB is parallel to DF and BD is a transversal. BD is a transversal and this angle A is 55 degrees because alternate interior angles are equal. So that's what is the first thing. Next, now we got A is 55. Now when A is 55, B is also 55 because again alternate interior angles. See here, parallel line, transversal, See, these are the two parallel lines. This one we are talking about this line and this line. So see here, parallel line, transversal, parallel line. See here, these two lines are parallel. This line is parallel to this line. So see here, parallel line. These are the two parallel lines, and this is the transversal. So we have a formation like this: parallel line, transversal, parallel line. So this angle, which is called A, is equal to B. Alternate interior angles are equal. See, these are the two parallel lines. It's marked double. You can see the double head arrows. These two lines are parallel. You cannot take a formation like this. You cannot take a formation like this where this is marked with a single arrow and this is marked with a double arrow. They are not parallel. If this is marked with a single arrow and this is marked with double arrows, they are not parallel. They are not parallel. See here. See, can you see this here? Double arrows. Transversal, double arrows. So parallel line, transversal. So this is the formation. This is the formation: parallel line, transversal, parallel line. So that Z kind of thing, parallel line, transversal, parallel line. Alternate interior angles are equal. A is equal to B. So you want to say that this angle is 55 degrees. So you name it B. You name it B. So A is equal to B. A is equal to B because BD, you can see here, BD is parallel to GF and DF is a transversal. Alternate interior angles are equal. Alternate interior angles are equal. Now this angle is marked 125 degrees. This is marked 125 degrees. When we started this answer, we did realize that since there are triangles, we can also use the property of exterior angles in a triangle. So 125 degrees is an exterior angle because that angle is formed when the side is produced, when the side EG is produced. When the side EG is produced to H, this exterior angle 125 degrees is formed. When the side EG is produced to H, this exterior angle 125 degrees is formed. That is the exterior angle FGH is formed. Exterior angle FGH is formed. Now, what is the property of the exterior angle? Exterior angle is equal to the sum of the two interior opposite angle. This is the exterior angle. Leave this interior angle, leave this one. So this angle is equal to this angle plus this angle. We saw this in the last class. So this is the exterior angle. This is its interior angle. Leave this one. 125 degrees is equal to x plus b. 125 degrees is equal to x plus b, or x plus b is equal to 125 because exterior angle is equal to sum of the two interior opposite angles. Now we found b is 55 degrees. B is 55. So x plus 55 is equal to 125. X is equal to 70 degrees. X is equal to 70 degrees. So now we found the value of x. We found x. Now we'll have to find y. Y can be found using linear pair. See, now before you do anything, you can find y straight away in the beginning itself because y and 125 form a linear pair. Y and 125 form a linear pair. So there itself you can find y. All right. So y you could have found it in even before finding x. So y plus 125. Y plus 125 is equal to 180. Linear pair axiom. What is it? Linear pair axiom. So when there's a straight line, okay, and a ray on it. So this is a ray which stands on the straight line. These two angles form a linear pair because these two angles stand on the same straight line. This is a straight line and there is a ray on it. This ray makes two angles on the straight line. This ray makes two angles on the straight line. The sum of these two angles is equal to 180 because these two angles are on the straight line. So y plus 125 is equal to, now all these are straight lines. It need not be given that, you know, AC is a straight line or whatever, AH is a straight line, need not be given. These are all line segments. Okay, so y plus 125 is equal to 180, linear pair axiom. So on working this, y is equal to 55. So like this, we find the values of x and y. So what you should understand is you must mention the parallel lines and the transversal when you use the properties of parallel lines. Yeah, and here is the exterior angle property. Any questions here, children?
No doubts, ma'am.
No, ma'am.
No doubts, ma'am.
I'll let you. So here, I've not written, the question is so big, so I've not written the question here, but you understand from the figure. You understand what is given here. So I've just written the question in short. You can see it here. AD divides angle BAC. AD, this AD divides angle BAC, which is BAC? BAC, this one. See, you should identify the arms of the angle. Which are the arms of the angle? You can make out from the name of the angle. Angle BAC, angle BAC. So BA and AC are the two arms. For angle BAC, BA and AC. BA and AC are the two arms. The vertex of the angle is at A. The angle is formed at A. BA and AC are the two arms. BA and AC are the two arms. So where is BA? Where is BAC? This is BA. This is BA. Where is AC? This is AC. So between these two arms, this is the angle. This is the angle. This full thing. This full thing is the angle. See, BAAC. This full thing. The angle in this V. BAAC. This full angle is angle BAC. Now it's given that angle BAC, AD divides. You can see here. This is BAC. AD, so this is BAC, this is BAC. So there's AD in between. AD divides this angle BAC in the ratio 1:3. So this is one part, this is three parts. You can see the angle. This is angle BAC. This is angle BAC. Now AD is here. AD is here like this. Now this ray AD or this line segment AD divides this full angle in the ratio 1:3. So if you call this one as X, this will be 3X. But since X is already used in the question, I've used A. I've called this A. Let this one be A. If this is A, this is 3A. Because the ratio is 1:3. So if this is A, this is 3A. So if this is A, this is 3A. And AD is equal to DB. AD is equal to DB. Where is AD? This is AD. AD is equal to DB. Where is DB? This one. AD is equal to DB. This line segment is equal to this line segment. So that means DAB is an isosceles triangle. Because if in a triangle when two sides are equal, it's an isosceles triangle. And if it's an when two sides are equal, the two base angles are also equal. I'll tell you what they are, which angles they are. So angle BAD is an isosceles triangle because these two sides are equal. BAD is an isosceles triangle. See, this side is equal to this side. So BAD is an isosceles triangle. All right. Now, now these two sides, BA and AD, these two equal sides, where do those two equal sides meet, children? Where do those two equal sides meet? See, this side, this is this one and this one. These are the two equal sides. Where do they meet?
Ma'am, D, ma'am.
Yeah, they meet a D, right? They meet, see, we just to understand, they meet a D. Leave that angle, leave that angle. Which are the remaining two angles? This one and the, see here, let me take that triangle separately like this. This is the triangle BAD, BAD. This is the triangle BAD. Now these two sides are equal. When these two sides are equal, these two sides, no, they meaning they diverge here. When they go like this, they are diverging. They're not meeting when they go like this. They converge here. They converge here at D. These two equal sides, you know, when you look at, when you go in this direction, when you go in this direction, the equal sides, they diverge. They're going in different directions. But where do they meet? Where do they converge? These two lines, they meet here. They meet here at D. Leave that angle formed at D. Leave that angle. The remaining two angles are equal. The remaining two angles are equal. You can remember like that. We will see. We will be proving why in an isosceles triangle, when two sides are equal, the two angles are equal, or when the two angles are equal, the two sides are equal. So we will be seeing the proofs for these statements. For now, to just solve this, we'll understand which two angles are equal. So again, in this triangle BAD, this side is equal to this side is given to us in the question. These two sides, they meet at D. There's an angle formed at D. Leave this angle. Leave that angle. The remaining two angles of the triangle are equal. In a triangle, when two sides are equal, two angles are also equal. In an isosceles triangle, two sides are equal and two angles are also equal. Which are those two angles in this triangle? These two angles are equal. It's not given. We only know that these two sides are equal. So since these two sides are equal, we know that from the theorem, when two sides are equal, two angles are also equal. These are the two equal angles. So this angle is equal to this angle. So you understand that when you find A and B are equal angles. So whatever is the measure of A is the measure of B. These two angles are equal angles. A is equal to B. Okay. All right, children. So now you know that now this angle is given to you. 108 is given to you. This angle is given to you. Now you can see a straight line. There are two rays on it. There are two rays. See, this is a straight line. This is a straight line. There is one ray like this. There's another one like this. And they make three angles here. 108, 3A, A. See here, this is 108, 3A, A. There is 108 here. There is 3A. Then there is A. All these three angles lie on the straight line. See here, all these three angles. This is the straight line. This is the straight line. This is the straight line. Like this is the straight line. There is 108 here. Start from here. 108. 3A. A. So when you start here, from here to here is 108. From here to here is 3A. From here to here is A. So see here, from this point, meaning I'm saying like it makes complete angle, half a complete angle, that is 180 degrees. From here to here, 180 degrees on the straight line. On the straight line, 108, 3A, A. This is 180 degrees. How do you mark 180? Like this, right? This is 180 degrees. When you start from here and you finish here, it's 180. Or when you start from here and you finish here, it's 180. It's 180. So 108 plus 3A plus A is equal to 180. That's what I've written here. Oh, by mistake, I think I've written 108 again here. Sorry. This is not 108, children. By mistake, 180 this is. All right. So the sum of the three angles on a straight line, linear pair. When do we say linear pair? That linear pair is only when there are two angles on a straight line. This is linear pair. When there are three angles, 1, 2, 3, we don't say linear pair because linear pair is only about two angles. This is sum of the angles on a straight line is equal to 180. Sum of the angles on a straight line is equal to 180. When there are more than two angles, then we say sum of the angles on a straight line is equal to 180. So 108 plus 3A plus A is equal to 180. So when you work that, you can find the value of A. You can find the value of A. And whatever is A is B. Whatever is A is B. Okay, whatever is the measure of angle A is B. Now you can find X. The question is to find X. X can be found using the exterior angle property in a triangle. So see here, this is the triangle. This is the triangle. Okay, there's X here. Leave the unwanted line segments. Leave the unwanted line segments. You don't want to see this one. Don't see. Don't try to see it. I'm drawing the triangle without that line segment. Without that line segment. This one we found because A is 18, B is also 18. So this is 18. This is X which we have to find. And there is 108 here. See only that one triangle. Don't forget the line segments going in between the triangle. Leave all that. See this triangle. We found this is 18. This is X which we have to find, and this is 108. So exterior angle property 108 is equal to 18 plus X, or X plus 18 is equal to 108. Exterior angle property in a triangle. This is the exterior angle. This is the immediate interior angle. Leave this one. Leave this one. These two angles. So exterior angle is equal to the sum of the two interior opposite angles. So X plus 18 is equal to 108. Or X plus B is equal to 108 because B is 18 degrees. So what do we do here? What do we do here? The ratio here is 1:3. This one is AD divides this angle in the ratio 1:3. BAC is the angle. BAC is the angle. AD divides that angle in the ratio 1:3. So this one is, A, and this is 3A. So first we do 108 plus 3A plus A is equal to 180, and we find the value of A. And then by isosceles triangle property, we know that A is equal to B. A is equal to B. So B is equal to 18 degrees. Isosceles triangle property, B is equal to 18 degrees. Okay, so B is 18. Now, by using the exterior angle property in a triangle, B plus X is equal to 108. And we find the value of X. X is 90. Is it fine, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So here there are no parallel lines. So simply don't think of alternate angles and all that. There's nothing here. There are no parallel, meaning two lines. Don't think of alternate because only when you have parallel lines, you can say alternate angles are equal. When you simply have two lines cut by a transversal, there are alternate angles, but there is no property. No, they're not equal. When the lines are not parallel, when there are simply two lines cut by a transversal, okay, there are alternate angles, there are corresponding angles, co-interior angles, but there is no property. They're simply alternate angles. They're not equal. So you should look for alternate corresponding co-interior angles only when the lines are parallel. Only when you have a pair of parallel lines, at least one pair of parallel lines. If you don't find parallel lines, don't even think of alternate corresponding and co-interior. Though such angles are formed, You cannot do anything with them further because there is no property. They're not equal or they're not supplementary. So then what else you can think? You can think of exterior angle property. You can think of vertically opposite angles are equal. Because vertically opposite angles are equal are irrespective of parallel lines because they're about intersecting lines. These two angles are equal. For that, you don't need parallel lines. You only need intersecting lines. Even in intersecting lines here, when two parallel lines are intersected by a transversal, these are vertically opposite angles. They're equal. So vertically opposite angles are everywhere. When two lines cut each other, vertically opposite angles are formed and they're equal. So it's not that when the lines are parallel, vertically opposite angles are not there. So you can see here, when two lines are intersected by a transversal, the lines may be parallel, may not be parallel. Whether they are parallel or not, here are vertically opposite angles and they're always equal. Whether the lines are parallel or not parallel. See here. Now say these two lines, they are not parallel, transversal. These two lines are parallel and this is the transversal. Vertically opposite angles. They are equal. Vertically opposite angles. They are equal. Whether the lines are parallel or not parallel. When two lines intersect, vertically opposite angles are equal. So this is a case where the two lines are not parallel, intersected by a transversal. So here vertically opposite angles are formed. They are equal. The lines are not parallel. Vertically opposite angles have nothing to do with parallel lines. And here also see vertically opposite angles are equal. Vertically opposite angles are equal. These two angles are equal. These two angles are equal. Here also, angle 1 is equal to angle 2, angle 3 is equal to 4, angle 5 is equal to angle 6, angle 7 is equal to angle 8. Vertically opposite angles are equal. So when you don't have parallel lines, you can think of vertically opposite angles, exterior angle property, isosceles triangle property. When two sides are equal, two angles are equal. So when we come to this theorem, we say when two sides are equal, the angles, or you can say angles opposite to equal sides in a triangle are equal. Angles opposite to equal sides. We'll come to that. We'll understand that later. Now you remember the way I told you. The two lines meet here. I told you like this, right? The two equal sides, they meet here. The two equal sides, they meet here. So leave that angle. The remaining two angles are equal. You remember like that now. So in the theorem, the statement will be angles opposite to equal sides of a triangle are equal. And sides opposite to equal angles. Sides opposite to equal angles in a triangle are equal. So that as a theorem, we'll see it later. Okay. So in the fourth one, you can see in the figure these arrows, which indicate that AB is parallel to CD, which indicate that AB is parallel to CD. AB is parallel to CD. So it won't be given, children. It will not be mentioned AB is parallel to CD. From the symbols, you should understand that these two lines are parallel. AB is parallel to CD. Okay, now the question is to find X, Y, and Z. So it's marked here, X, Y, and Z. So parallel lines. So you can use alternate corresponding co-interior. You can use vertically opposite angles are equal, and there are triangles, maybe exterior angle property. So you should think of all this. Am I audible, children?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
All right, yeah. Tanishka, Krishmi, Sindhu, Sanjay, Raja, Netra, Krishmika, and Danya. All right, children. All of you had school today?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
No, ma'am.
No, ma'am.
How many know? Oh, Montfort, huh? Krishmi, Raja, Sindhu, Sanjay. Okay. For Montfort, it was a holiday. All right. Okay, fine. All right. Yeah. So when when we have parallel lines, so here we have parallel lines. AB is parallel to CD. So now let's see how to find x, y, and z. Normally we find in the order, children. Normally, you can see when you're asked to find x, y, and z, normally we find in the order. We find x and then find y and then find z. But it's okay if you find z first and then x and then y. It's okay. It's not wrong. You will not lose marks for that. But normally we find in the order. X, y, find x, y, z. So we'll find x and then y and then z. Okay. So how to find x? See here, parallel line, transversal, parallel line. See here like this, parallel line, transversal, parallel line. Here are alternate interior angles, they're equal. This is 35 and this is x. See, don't get confused with the line which is going like this. You take up only those lines which are needed for you to use the property. You know that when a transversal intersects two parallel lines, when a transversal intersects two lines, alternate angles are formed. But when a transversal intersects two parallel lines, the alternate angles formed are equal. When a transversal intersects two lines, corresponding angles are formed. But when a transversal intersects two parallel lines, the corresponding angles formed are equal. When a transversal intersects two lines, co-interior angles or allied angles, they're also called conjoined angles. Allied angles, conjoined angles, consecutive interior angles, or interior angles on the same side of the transversal. So when a transversal intersects two lines, allied angles are formed. Allied angles are formed. But when a transversal intersects two parallel lines, the allied angles formed are supplementary. Allied angles are supplementary when the lines are parallel. If the lines are not parallel, they are allied angles, but they are not supplementary. Okay, so see here, parallel line, transversal, parallel line. Here and here are the alternate interior angles. So you can see here, 35x, parallel line, transversal, parallel line. So x is equal to 35 degrees. Alternate interior angles are equal. So which are the parallel lines? AB is parallel to CD. Which is a transversal? See here, parallel line, transversal, parallel line. What is this called? This is called DC. What is this one? Oh no, it's not like this. It's not like this. It's like this. Parallel line here, parallel line, transversal, parallel like this. So it's B, A, D, C. Yeah. So this is X and this is 35. So you can see from this figure, AB is parallel to CD. AB is parallel to CD. See, AB is parallel to CD. And BC is a transversal. See, BC is a transversal. BC is a transversal BC. Trans meaning transversal BC. I said you should mention the parallel lines and the transversal. So in short, I've written transversal BC. Or you can say BC is the transversal. You must mention the parallel lines and the transversal. So these are the two. So from this figure, you can make out AB is parallel to CD and BC or CB, anything. BC or CB is the transversal. Alternate interior angles are equal. Alternate interior angles are equal. So X is equal to 35 degrees. Then let's find Y. Let's find Y. So angle sum property in a triangle. We know that in a triangle, the sum of the three angles formed is equal to 180 degrees. So we use that property to find Y because we found X. We found X is 35. And you see that in this triangle, we know two angles. You have to find the third one. Here in this triangle, you know X, which is 35. We just found. And this is 75. So you can use the angle sum property to find Y. In a triangle, when you know two angles, you can find the third one using angle sum property. In a triangle, when you know two angles, you can find the third one using angle sum property. So that's how we find Y. In this triangle, you can mark this point O and you can say in triangle ABO. You can mark this point O and you can say in triangle ABO x plus y plus 75 is equal to 180. Because reason, sum of the angles in a triangle is equal to 180 degrees. So you understand this. You have to substitute for x, solve and find y, which is 70 degrees. 70 degrees. And z straight away. Alternate interior angles here. Parallel line, transversal, parallel line. Parallel line, transversal, parallel line. This is BA. This is DC. And here are the angles, 75 and Z. This is Z, this is 75. So Z is equal to 75, alternate interior angles are equal. So AB is parallel to CD and AD is a transversal. AD is a transversal. What is a transversal? What is a transversal? A transversal is a line that intersects two or more lines. So supposing there are many lines like this, 1, 2, 3, 4. This line is a transversal because it cuts all the four lines at distinct points, Now, when there is one line and when you draw a line like this is not a transversal. There is one line, when there is a line like this and you draw a line like this is not a transversal. You can't say that this is a transversal. There should be at least two lines. Transversal is a term used when there are at least two lines. There should be at least two lines. So two lines. And there's a line that goes like this. So why is this line called a transversal? Because this line cuts the first line at this point and the second line at this point. This line which is a transversal, intersects, supposing I call this line 1 and line 2. So the transversal cuts line 1 at this point and cuts line 2 at this point. So a transversal is a line that intersects two or more lines at distinct points. Distinct meaning different points. A transversal is a line that intersects two or more lines, two or more than two lines at different or distinct points. So 1, 2, 3 lines. They may be parallel, may not be parallel, that's okay. So if you call this line 1, line 2, and line 3, and if you call this 4 as a transversal, 4 is a transversal because 4 intersects 1 at this point, 4 intersects 2 at this point, 4 intersects 3 at this point. So 4 intersects 1, 2, and 3 at distinct points, at different points. 1, 2, and 3 are the lines. 4 is a transversal because 4 intersects 1, 2, and 3 at distinct points, at different points. A transversal is a line that intersects two or more lines at distinct points. So parallel line, transversal, parallel line. 75 Z. Alternate interior angles are equal. Alternate interior angles are equal. Only when you draw this figure, you can write the parallel lines and transversal, children. So this is B, this is A, this is D, this is C. And there's Z here and there's 75 here. So Z is equal to 75. Alternate interior angles are equal. This is equal. Instead of writing EQ UAL, I've just put the symbol equal like this. You should write EQ UAL, children. In school, don't write like this. And don't write short form trans and all that. You must write transversal. This is not the, I've just used this short form. This is not a standard one. Don't write trans and don't use the equal to sign like this. Write equal. So from this figure, you can make out that AB is parallel to CD and AD is a transversal. AD, not BC. AD is a transversal. So how did we find X? Alternate interior angles are equal. How did we find Y? Y because using angle sum property in a triangle. And Z, alternate interior angles are equal. Any questions, children?
No doubts, ma'am.
All right. Yeah, children. Next one. So we all know that the measure of a complete angle, the measure of a complete angle is 360 degrees. The measure of a complete angle. So complete angle is now around a point. Okay, when there are many angles formed around a point. Now, supposing I call this angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. So angle 1 plus 2, angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8 is equal to 360 degrees. Because these 8 angles are formed around the same point. This is the point. Around that point, all these 8 angles are formed. Not that 8 angles should be formed. Maybe 5 angles are formed around a point. See, like this. There's a line like, say, like the figure is like this, like 1, 1, 2. Yeah, like this. Okay, so 1. This is 1, 2, 3, 4, 5. Just a minute, children. I'm getting a call. Yeah. So here 5 angles are formed around this point. Around this point, see here 1, 2, see here 1, it continues 2, then again 3. There's no break. Then it continues like this 4, and then see you come back to the starting point 5. So you can start from anywhere. You can even start from here 3, from here 3, from then continues from this. Here this is 3. It continues. This is 4. It continues. This is 5. It continues. This is 1. And this is 2. You come back to the starting point. So you like started here and you made one full round. You come back here. Sum of all the angles formed around this point is equal to 360 degrees. So maybe, 3 angles, 4 angles, 5 angles, how many other angles formed around a point, their sum is equal to 360 degrees. And, so here you can find vertically opposite angles. So vertically opposite angles are equal. Vertically opposite angles formed are equal. Sum of the angles on a straight line is equal to 180. Sum of all the angles formed on a straight line is equal to 180 degrees. Sum of all the angles around a point is equal to 360 degrees. Vertically opposite angles are equal. Okay, so here we need to find x, y, z, and t. Well, we know that this symbol stands for 90 degrees. This symbol stands for 90. The symbol, so it's not, so they will not mark this and say 90 degrees. No, if they've used that symbol, it means it is 90 degrees. This symbol means 90 degrees. All right. So we need to find x, y, z, and t. From this figure, we need to find x, y, z, and t. All right. Now, we should be very careful while identifying, vertically opposite angles. You should be very careful. All right. Now, I told you. So to answer in this figure, to answer or to find x, y, and z, x, y, z, and t here, you can look for vertically opposite angles. There will be, see, there are 2 or more lines are meeting at a point. So definitely there'll be vertically opposite angles formed and they are equal. Or then you can use a straight line. You can find the straight line and the angles on the straight line. The sum of the angles formed on a straight line is equal to 180 degrees. You can use vertically opposite angles are equal here. Sum of all the angles formed on a straight line is equal to 180. Okay, so you can see, if you want to go by the order, you want to find x first. Then see, you can see the straight line here. This is straight line. And you can see from here, x, it continues 50, continues 90. Agree, all of you? All of you agree?
Yes, ma'am.
Yes, ma'am.
Yeah. This is a straight line. This is the straight line. This is a straight line. See, you start from here. Like this is a straight line. You start from here. This is x. This is 50 and this is 90. So we come, see, on a straight line, You start from here and land here, 180. Or you start from here and you land here, that's 180. So see, from here to here, X. Then it continues. Now don't say it's not continuing here, it is 50. That means this is also 50 only. We know that. It's not that because it's marked 50 here, it's not continuing. It is continuing. This angle is 50 degrees. This is 50. And it continues. This is 90. This is 90. Okay, just in case you feel so. See here, children. This is 50 degrees. This one is only 50. And this one is 90 degrees. So X plus 50 plus 90. See, you started here and you land here on the straight line. So 180. The sum is 180. Sum is 180. So how do you put that? X plus 50 plus 90. X plus 50 plus 90 is equal to 180. X plus 50 plus 90 is equal to 180. Reason, sum of all the angles on a straight line is equal to 180. So on working this, X is equal to 40. X is equal to 40. Now X is 40. So Y is also 40 because vertically opposite angles are equal. So take only those two lines. Now don't take this line. This is not needed. This will confuse you. Don't take this line. Now can you see the two lines intersecting? X and Y are vertically opposite angles. They are equal. Can you see that?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Yeah. To identify vertically opposite angles, sorry. To identify vertically opposite angles, look at only those two lines. If there are many lines and it's confusing you, don't consider the remaining lines. Consider only those two lines. So you can see X here and there is Y here. So vertically opposite angles are equal. All right. So since you found X, it's easy to find Y. X is equal to Y. Vertically, V meaning vertically, O is opposite. Don't use these short forms. They're not standard ones. V is vertically, O is opposite, angles are equal. This is not zero. Vertically opposite angles are equal. So X is equal to Y. Vertically opposite angles are equal. So X is 40, which means Y is also 40. X is 40, so Y is also 40. Now see here. Now see these two lines. This line. See this line and this line. This line. These two lines. Can you see? Now you can see here. 50 and Z. Vertically opposite angles are equal. I've marked. I'll just give you some time to watch that. So this one and this one. Vertically opposite angles are equal. So Z is equal to 50 degrees. Z is equal to 50 degrees. Vertically opposite angles are equal. Again, look at these two lines. This line. This line. You can see there is T here and there's 90 here. So T is equal to 90. Vertically opposite angles are equal. That's what I've written here. Vertically opposite angles are equal. T is equal to 90. Vertically opposite angles are equal. So we found only X using the property that the sum of all the angles formed on a straight line is equal to 180 degrees. Sum of all the angles formed on a straight line is equal to 180. Using that, we found X. Then we found all the others using using the property that vertically opposite angles formed are equal. Is that fine, children?
Yes, ma'am. Yes, ma'am.
All right.
Yes, ma'am.
Very good, children. So here there are no parallel lines. So don't think of this. So you have, it has nothing to do, meaning you don't have, see, I'm not saying there may be two lines and a transversal. Even then don't think of, there may be two lines and a transversal. Then also don't think of alternate corresponding co-interior because no property. Their alternate angles are there, but they're not equal. Co-interior angles are there, but they're not supplementary. Only when you see a pair of parallel lines and transversal, you should think of alternate corresponding and co-interior. Otherwise, don't even think of them. So you can always find, if you find a triangle, you can use the property sum of the angles. If you find a triangle, you can use the property sum of all the three angles in a triangle is equal to 180. And if you find an exterior angle, that is when a side is produced, exterior angle is found. So exterior angle is equal to sum of the two interior opposite angles. Or in a triangle, when two sides are equal, two angles will be equal. Sum of all the angles on a straight line is equal to 180 degrees. Vertically opposite angles are equal. So all this should run in your mind when you have to, find the missing or unknown angles. Vertically opposite angles are equal. The sum of the three angles in a triangle is equal to 180 degrees. Exterior angle is equal to the sum of the two interior opposite angles. In a triangle, when two sides are equal, actually it is like this. The angles opposite to equal sides of a triangle are equal. Angles opposite to equal sides of a triangle are equal. That's what I've just told you as, in a triangle, when two sides are equal, two angles are equal. I told you which two angles will be equal. Those two equal sides will meet somewhere. Leave that angle. The remaining two angles will be equal. See the next one. So for parallel lines, it's indicated, the arrows indicate that they are, parallel. This arrow indicates that they are parallel lines. So in this figure, you can see a triangle. So maybe, exterior angle property, you can see a triangle, not a triangle. You can see there is one little triangle also here like this. So triangles, you can see triangles, you can see, intersecting lines. Maybe vertically opposite angles are equal. Here also vertically opposite angles are equal. So like that. So if you want to see, instead of, how will you name this angle? Name this angle. I've called it A. Otherwise, how do you name this angle, children? Use three letters and name angle A.
Angle FEG, ma'am.
Yeah, it is right there. FEG or FEG or
GEF.
GEF. GEF. Because the angle is here. So which are the arms of the angle? This one and this one. These are the angles, arms of the angle. You can also call it QEF. Correct? QEF. You need to identify the arms of the angle. These are the arms of the angle. These are the arms of the angle. So you can call that angle F. Put the vertex in the middle. FEG or FEQ. QEF. Okay, how will you name this angle?
RFA.
RFA or
AFR.
AFR. AFR. Yeah, AFR. How do you name this angle?
Angle PEF. Or FA.
PEF or FEP. Correct. All right. So now when you're working, when you use letters like this to represent angles, it's easy to check your answer, is what I feel. So that's why wherever if I'm finding this angle, I'll just mark it A and I'll say A is equal to whatever. You can also use three letters to name the angle. So that again is your choice, your convenience. Okay, so I want to find this angle. See, how do you know that you'll have to mark this angle as A and this angle as B? First, when you look at the figure, you plan something, right? You cannot just start working. You cannot just start working. See, it's not an equation given to you. If I give you an equation like this, supposing, an equation like this given to you, a simple one like this. So 2x plus 7 by 5 minus 3x plus 11 is equal to 19. If I give you an equation like this, there's not much you have to plan like. So, you have to, add the like terms and LCM, meaning work with the numbers and all that. So this more or less you'll start working. As soon as you see this, you'll start working 2x minus 3x is minus x, and you'll start taking the LCM and all that. But when it comes to a question like this, where you have a figure and you'll have to find the unknown angles, you need to actually look at the figure and plan. Okay, let me find this first, and then using this, let me find this, and then using that, let me find this. So you do some, you first look at the figure and you understand the information given and you plan, and then you execute your plan. So when you plan, you will know, okay, let me call this one A, let me call this one B. So that's how you mark A and B. That's how you mark A and B. Okay. So here we need to find X. You need to find X, this angle X. I'll explain this to you, and maybe we can think if there is any other way of finding it also. So sometimes this may not be the only way. There may be a different way, a different approach to find this answer. So let me explain what I have worked here, and we'll see if it can be worked in a different way also. Okay, so what I've done is I've found A using linear paraxium, because only two angles. You see here, this is a straight line. This is a straight line from here to here. See 180. See, this is a straight line. This is a straight line from here to here, 180. So 85 plus A is equal to 180. 85 plus A, 85 plus A is equal to 180. So that way you can find A, 95 degrees. A is 95 degrees. Then you can see the arrows here and here. So these two lines are parallel. This line is parallel to this line, or this line is parallel to this line, or these two are parallel lines. Parallel lines transversal. Okay, now I have marked this one as B, and I'm finding B with the help of A. What is the relation between A and B? So there are two parallel lines intersected by a transversal. You need to identify the relation between these two angles. So you can see that both the angles lie on the same side of the transversal. So they are not alternate angles, because alternate angles lie on either sides of the transversal. So these two angles, they lie on the same side of the transversal. So they are not alternate angles. We'll see if they are corresponding angles. They are not co-interior angles, because if they are co-interior angles, both of them should be interior angles. But here one is exterior, one is interior. This is an exterior angle. This is an interior angle. So these two angles, they lie on the same side of the transversal. One is an exterior angle, one is an interior angle. So they may be corresponding angles. You can see that. See, and one more thing is, when it's corresponding angles, both will be above the line like this, or both will be below the line like this. Okay, you can just use this one. See, when they are corresponding angles, they lie on the same side of the transversal. One of it will be an interior angle, the other will be an exterior angle. See here, one angle is here, the other angle is here. This is an exterior angle. This is an interior angle. Now you might think that if this is an exterior angle, this is an interior angle. 1 minute. I'll just clarify that. You will say that this one is exterior, okay, and this one is interior. Then this is exterior, this is interior, so they are, and they lie on the same side of the transversal, so they are corresponding angles. So please see, we are just trying, to remember or to understand or to mark the angles with some, definitions. So don't bring this doubt in the middle. Meaning, this is an exterior angle, this is an interior angle. They lie on the same side of the transversal, but you know that they are not corresponding angles, so they form a linear pair. They form a linear pair. The sum of these two angles is 180. The sum of these two angles is 180. Yes, this is an interior angle. Yes, this is an interior angle. This is an interior angle. This is an exterior angle. But the sum of these two angles is 180. So not this kind of interior exterior angles. So I hope all of you now understand transversal. This is an exterior angle. Outside it is. And this is an interior angle. This is inside. They lie on the same side of the transversal. These two angles lie on the same side of the transversal. One is an exterior angle, the other is an interior angle. Then they're corresponding angles and they're equal. Corresponding angles lie on the same side of the transversal. One of it will be an interior angle, the other will be an exterior angle. Then they are corresponding angles and they are equal. So by that definition, these two angles are corresponding angles, because parallel lines transversal. Look at only this part. Don't look at this line. Don't look at that line. Look at only the relevant lines. These two lines are parallel to each other. And this is the transversal. This is the transversal. Now don't get distracted by the other lines. Now see here. This is an interior angle. This is an exterior angle. See, from the transversal till the parallel line you should come. Okay, let me tell you that way also. See here. From the transversal you should come till the parallel line. That is the complete angle. See here, from the transversal, this is a transversal, till the parallel line, that is one complete angle. That is complete meaning not 360. That is that full angle we are talking about. See here, from the transversal till the parallel line, or from the parallel line till the transversal, from the parallel line till the transversal, the same transversal. See, yes, the same transversal. From the parallel line till the transversal, parallel line, transversal. This is interior. This is the exterior angle. They are on the same side of the transversal. Both of them are on the same side of the transversal. They are corresponding angles. They are corresponding angles. So by that definition, you can see here, from the parallel line till the transversal, A. Parallel line till the transversal, B. Same side. One is exterior, one is interior. Corresponding angles. I'll show you again. This is the parallel line till the transversal, A. This is the parallel line till the transversal, B. B is exterior, A is interior, and they are on the same side of the transversal. They are corresponding angles. So A and B are corresponding angles and they are equal. A and B are corresponding angles and they are equal. So see here. So first you find A using a linear paraxium. A using linear paraxium, 95 degrees. Then A is equal to B. Corresponding angles are equal. Please mention the parallel lines. Whatever, they are parallel. This is the transversal. So corresponding angles are equal. So B is 95 degrees. Now we find X using exterior angle property in a triangle. This is the exterior angle. This is this is the triangle. Are we all listening, children?
Yes, ma'am.
So children, see, this is that little triangle. This is that little triangle. This is the side which is produced. This side is produced here like this. So this is the exterior angle. See here, this is the exterior angle. The exterior angle, see here, it will come from one side of the triangle. This is one side of the triangle, no? From there it will touch that side which is produced. This is the side which is produced. This is the side which is produced. So from here, it will touch the side of the triangle. That is the complete angle. That's the exterior angle. 115 degrees is equal to B plus X, because this is the interior angle. Leave that. 115 is equal to B plus X. See, you can magnify the triangle. It's like this. The triangle is like this. You can magnify it. Here is the exterior angle, 115 degrees. Here is B and here is X. This is that interior angle. Leave that. This is the exterior angle. This is its interior angle. This is the exterior angle. This is its interior angle. Leave this one. The remaining two angles. 115 is equal to X plus B. 115 is equal to X plus B. Exterior angle property. We found B, so substitute that. So X plus 95 is equal to 115. X is equal to 20 degrees. So like that we find X. So we had to find X. X is 20 degrees. Now children, I'll just give you some time. See, it may be a roundabout also, that's okay. But I want you to think differently. It can take a few more steps also. Maybe you feel, no, here we get it in 2 steps. I need 5 steps to get. That's okay. But I'll be happy if you can think in a different way. I'll also have a glass of water and come back. I'll give you 5 minutes time. Think differently. And let me know how else you can find angle X. I'll just come back, children. Please think about a different way to find X in question number 6. Yeah, children, I'm back. Who wants to share first?
Ma'am,
Yeah,
we
then.
can,
Yeah. Yes,
ma'am, I
Daniel.
can find by angle some property, ma'am.
Okay. Tell me how.
So we found that angle B is equal to 95 degrees, ma'am. And then by finding angle GHQ, ma'am.
Okay. Okay. Okay,
So
fine. So what? Okay. So what Danya is telling us, instead of using the exterior angle property, so she says find A and B in the same way, and then she wants to mark this one as C. She says find A and B as usual. Take this one as C and say 115 plus C is equal to 180. Correct, Danya?
yes, ma'am.
Correct. Okay. So Danya says find A and B as usual. Mark this one as C. Mark this one as C, and say 115 plus C is equal to 180. So C is equal to 180 minus 115, which is 65 degrees.
65 degrees, ma'am.
Now she says X plus B plus C is equal to 180. Correct?
Yes, ma'am.
Yeah, X is what we have to find. B we found is the 85 and C is 65 is equal to 180. And X is equal to whatever 150, 30 degrees. No, 140, 150.
20, ma'am. 20 degrees.
No, I'm getting 30 here. 18, 60 is 140, right? 140. No, I've gone wrong somewhere. Oh, this is 95.
160, ma'am.
No, A is 95. B is 95. I didn't. X plus B plus C is equal to 180. X plus B is 95. I wrote 85. Plus C. How much is C? 65 is equal to 180. Yeah, X is equal to 20. Okay. Anybody else? Anybody else? You can do this in many ways.
Ma'am,
Yeah.
ma'am, I did this in same method, ma'am.
Vishmika, is it?
Ma'am,
Okay, same method. Okay. Okay, let me share something else. See, supposing, I start with 115. Supposing forget this A and B, okay? We have not marked anything. We have not marked anything. We just have this figure. Now, supposing we start with 115. So I can say vertically opposite angles are equal. So this is also 115. Is this correct?
Yes, ma'am.
Okay, this is correct. Okay, fine. This is correct. So first step I can say, yeah, very good. So first step I can say this angle is 115 degrees, vertically opposite angles are equal. Okay. Then next, I mark this one. So I call this one as A. A is equal to 115 degrees, vertically opposite angles are equal. I mark this as B. I mark this as B. Now A plus B is equal to 180 because co-interior angles are supplementary. Why A and B are now here this A and B, why are they co-interior angles? Because we have two parallel lines and this is the transversal. This is 115 degrees and I'm calling this B. This is A, this is B. You can see that A and B are interior angles. A and B are interior angles. Both of them are interior angles and they are on the same side of the transversal. What are co-interior angles? Both of them will be interior angles and both of them will be on the same side of the transversal. Co-interior. Both are interior angles. And both will lie on the same side of the transversal. Allied angles, conjoined angles, co-interior angles are two angles that lie on the same side of the transversal. Both are interior angles. There are two interior angles lying on the same side of the transversal. So you can see that A and B are interior angles and they lie on the same side of the transversal. So they're allied angles. They're supplementary. A plus B is equal to 180. So 115 plus B is equal to 180. B is equal to 180 minus 115, which is 65 degrees. So you get B is 65. You get B is 65 degrees, this one. This is 65 degrees. So having found B now, this is the triangle. I'm taking this big triangle now. This is the big triangle. Okay, I found that this is 65. Now exterior angle property. X plus 65 is equal to 85. Because for 85 degrees, this is the interior angle. For 85 degrees, this is the interior angle. These are the two interior opposite angles, 65 and X. Don't see this line in the middle. Don't just see the triangle. See that picture completely. Take away all those lines which run through it. See only the triangle. All the lines which run through it, take it away. So see here. See here, don't see this line. Don't see this line. Take it away. Erase it. Erase it. Don't see this. So this is the triangle. EQF is a triangle. This is the triangle. 85 is the exterior angle. This is its interior angle. Leave this. These are the two opposite angles, interior opposite angles. So 85 is equal to, we found this, no, 65 plus X. 65 plus X. So X is equal to 85 minus 65, which is 20 degrees. So you can also do it like this. You can do it and see there are at least 4 ways of doing it. At least 4. So you can do it like this. So what did I do? This is 115. So we found this vertically opposite angles are equal. So this is 115. Then this angle and this angle. See, they are parallel lines. Co-interior angles are supplementary only when the lines are parallel, not otherwise. So see, these are the two parallel lines. These are the two parallel lines, and this is the transversal. This one is a transversal. This one is a transversal. Not this one, not this one, not this one. So this is the transversal. So here, see, on the same side, we have two angles like this. On the same side of the transversal. This is the transversal. See, from the parallel line till the transversal. From the parallel line till the transversal. These are two angles. They are on the same side of the transversal, and both of them are interior angles. So they are co-interior angles. They are supplementary. This is 115. Vertically opposite angles are equal. So then vertically opposite angles are equal. So this 115. Now co-interior angles are supplementary. So this will be 65. Now 85 is equal to 65 plus X. Exterior angle property in a triangle. So we used vertically opposite angles first, and then co-interior angles are supplementary. 2. Then exterior angle property in a triangle. 3. First vertically opposite angles. Next allied angles are supplementary. Then exterior angle property in a triangle. So accordingly, you should mark, if this is your plan, accordingly, you should mark A here. You must write A is equal to 115 degrees, vertically opposite angles are equal. Then you must mark B here. According to this plan, you should mark B here. You should not mark these angles. You should mark B here. You must say A plus B is equal to 180. Co-interior angles are supplementary. 115 plus B is equal to 180. B is equal to 65. So you'll get B 65. Then you should use the exterior angle property in a triangle. X plus B is equal to 85. This X. You can mention the triangle. In triangle EQF. In triangle EQF. In triangle EQF. 85 is equal to X plus B. 85 is equal to X plus B. Exterior angle property in a triangle, and then you should find X. Is it clear, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. All right, children. Yeah, who can explain the next one? Go through the answer. We'll wind up today's session with this one. We'll wind up today's session with this one. So this is the, I've given you the overall idea of lines and angles. This is how we'll be dealing with lines and angles. So I know, so you got an idea. Now I think things should be clear, but we will be solving more questions, more situations like this. But have you got some idea about the chapter, children? This is all about lines and angles. Did you all get some idea about the chapter?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
These are the, the rules which we'll be using. Alternate angles equal, corresponding angles equal, co-interior angle supplementary, vertically opposite angles equal, exterior angle property in a triangle. In a triangle, when two sides are equal, the angles opposite to them are also equal. Linear pair axiom. Sum of the angles on a straight line is equal to 180. Sum of the angles around a point is equal to 360 degrees. So all this should be in your mind when you're solving a, a situation like this. All this should come to your mind. Okay. Yeah, please go through the 7th one and explain. Somebody explain that for me. Yeah, children. All right. Fine. So only x, see, find x meaning only x will be marked in the figure. Only x will be marked. So you mark A because you want to find A. To find x, you want to find A. So you mark A. So you can say how many pairs of parallel lines can you see here? How many pairs? Two pairs. Two pairs. See, so it's not a small line like this. It's a line. You can produce it like this. See here, you can produce the parallel lines like this. See here, you can produce the transversals like this. You can see the figure like this. Produce them. So now first you can take up these two lines are parallel. These two lines are parallel to each other. These two lines are parallel and this is the transversal. This is the transversal. So parallel lines, transversal. See here, interior angle, interior angle. On the same side of the transversal, co-interior angles. Parallel lines, transversal, same side of the transversal, interior angles. So they are co-interior angles and they're supplementary because the lines are parallel. They're supplementary. So A plus 75 is equal to 180. I've mentioned the parallel lines and the transversal co-interior angles are supplementary. So you get A is equal to 105. Now we are taking a different set of parallel lines. This line, this one is parallel to this one. This is parallel to this. Now a different set, the other set of parallel lines. This is parallel to this. And this one is a transversal. Let me clear it. So now we are taking this line. This is parallel to this. These two lines are parallel, and this one is a transversal. See it? Can you see that? Parallel line, transversal, parallel line. Alternate angles are equal. X is equal to A. Alternate interior angles are equal. So because A is 105, X is also 105. Parallel line, transversal, parallel line. Or like this. See it? Parallel line, transversal, parallel line. Here, alternate angles are equal. These two lines are parallel. These two lines are parallel, and this is the transversal. You can produce them. See, produce it like this, produce it. So you can see now, these are alternate angles because they are on the opposite sides of the transversal, and both are interior angles. They are on either sides of the transversal, and both are interior angles. So they are alternate interior angles, and they're equal. Practice the same sums, children. It's really, I'll tell you, it's not about working 100 sums. It's about working 10 sums and understanding them thoroughly. It's definitely not about working 100 sums. So everything you understand as you work and then you forget, nothing stays in your mind. It's about working, using different concepts in 10, 15 sums and repeating them and understanding them very clearly. Believe me, this will work. So practice the same sums, go through all these 7 sums again. So then you become very fast in applying the, concepts, alternate, corresponding, co-interior, everything comes to you very fast in your mind. Once you're very sure about the concepts, then you can work different sums. But till you master it, you can master only with a few sums. You cannot master by working 1,000 sums. First to master it, pick few sums. Keep doing them over and over. Because now, see, pick few sums, meaning pick the sums which I have taught you, because these have all the ideas in it. These have all the ideas in it. So work the same thing many times. Then you become very confident. Then explore. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you, children.